Okay, Dragons, this lesson I'm just going to do a problem. I'm not going to have you fill in notes just yet. You can do that after you watch a couple of examples. But I just want you to watch, write down an example, and then if you have questions, you can ask. The process will be the same. We're going to be factoring trinomials. Trinomials in standard forms are ax squared plus bx plus c. So in this case, a is the number in front of x squared, so a is 3. B is in front of the x, so b in this case is a positive 11. And then c, which is not multiplied by x or x squared, is the number at the end. And in this case, it's going to be a negative 4. So we're going to identify a, b, and c. Normally, you would have to look at this trinomial and factor out a GCF. We're just going to give you problems where you don't have to worry about a GCF. You will in future math classes, so be prepared. Don't say, well, they never told us. We'll probably do some of these later on, but right now we're just going to look at it. And what I mean by that, if you look at A, B, and C, if you look at 3, 11, and negative 4, the only common number that will divide all three of them evenly is 1. That's what I mean by GCF for A, B, and C equaling 1. Here's how you do it. I'm going to start off by making, no, not an X, but a star. This is going to be our graphic organizer. Okay, so we are factoring this. Here's what we're going to do. We're going to multiply the first number times the last number. So that's a positive 3 times a negative 4. And where do those go? That answer goes up top. Okay? Multiply the first number times the last number, put it on top. Look at your middle number. Look at B. In this case, it's 11. This goes directly at the bottom. So that's a positive 11. Okay? 3 times negative 4 is 12. Put it in the top slot. Just look at the middle term. Put it in the bottom spot. Make sure you take a look at the sign. Okay? So now, here's where we're going to start doing some different stuff. We need to be thinking, what will multiply to negative 12, but add to 11? And it has to be the same numbers working for both of these. So if I'm multiplying to get a negative, I know that I have to have a positive times a negative, because a positive times a negative is a negative. So what are some of the ways that I can multiply to negative 12? Well, I can do negative 1 times 12. I could do a positive 1 times a negative 12. I could do a negative 2 times 6, or I could do a positive 2 times 6. I could also do the 3 times a negative 4, or the negative 3 times a positive 4. So there are a variety of ways that I can multiply to get a negative 12, but only one of these will turn around and add to a positive 11. And the one that I need to pick in this particular case is going to be the positive 12 times a negative 1. And I'm going to put those down here at the bottom two remaining slots. So take a look at these two numbers right here. Do they fulfill the requirements of multiplying to a negative 12? Positive 12 times a negative 1 is a negative 12. And if I turn around and now add these, if I take 12 minus 1, do I get 11? Yes. Okay. So we found our two numbers that do both of these things. Now I'm going to go back to the original problem, and I'm going to steal A. I'm going to take A, and I'm going to put it in the two remaining spots. Here and here. And now all of my focus is going to turn to these two boxes. And in a way, they look like fractions, right? This looks like 3 over 12, and this looks like 3 over negative 1. And that's what I want you to do. I want you to think of these as fractions, okay? Now, if you can reduce 3 over 12, if you can reduce it, you must. So if you kind of stink at reducing fractions, I want you to do your alpha y equals, and type it in. 3 over 12, what does that reduce to? 1/4. So this reduces to 1/4. So you're going to reduce that to 1 over 4. Okay? Now, what can reduce this? Well, this is already reduced because the only number that can go into both of these is 1. Anytime a fraction can only be divided by 1 evenly, both the numerator and the denominator, you're done. So this one is okay. This one's already reduced. Yes, it's improper, but it's reduced. All right, you ready for the magic? Because we're about done. What we're going to do is we're going to say that this fraction is going to help us make our first binomial. And what we're going to do is we're going to take this number right here, and that's going to be my coefficient of x. Because I need an x squared, so I'm going to have an x times x. So this is one of my x's. And because that's a 1, this is going to be 1x. Guess where this 4 is going to go? Right there. And so one of my factors is going to be x plus 4. Okay? Let's look over here. This fraction over here on the right is going to produce the other factor. It's already reduced, so the top number will go in the front, in front of an x, and the bottom number by itself will come over here and be a -1. So if I bring this down here, guess what happens if you multiply these two together? Go ahead and try that. Do a box method, because if I gave you these two and said, hey, multiply them, you would get this. Let's do another one. We're going to factor this. Notice the only number that can divide 2, 3, and 9 is 1. Here we go. So we are going to make our star, and we're going to multiply a times c. 2 times -9, 2 times -9. A positive times a negative is a -18. Goes on top. My middle number, just by looking at it, my middle coefficient is a +3. So I need two numbers that will multiply to -18, but add to a +3. Now, some of you will need to list those out. Some of you are good at knowing how things multiply, but what you need to do is you just need to run the gamut of this. You might want to start with numbers that are close to each other, like 3 times -6. 3 times -6 is a -18. Well, what happens whenever I add them? 3 plus a -6 is a -3. Ooh, that's close. So all I'm going to do here is switch the signs. Okay, so if I do a -3 times a +6, I get -18. And if I add a -3 plus a +6, I get a +3. This is the combination that I want because it does two things. These two numbers multiply to a -18 and add to 3 at the same time. Now, it doesn't matter where you put the 6 and the -3, potato, potato. I'm just going to put a -3 here, and I'm going to put a 6 here. Okay, those are the two numbers that fulfill the north-south requirements. All right, where do I go now? I go back to the original problem, and I steal A, which is 2. I put a 2 here, put a 2 there. Okay, so now we're going to focus on our fractions. Look over here. That one right there, and that one right here. This is all we're looking at right now, are these two green boxes. Can 2 or -2/3 be reduced any further? Okay, so if you do an alpha y equals, if you do a 2 over -3, and you ask the calculator to reduce it, it's already reduced. It doesn't do anything. The only number that can divide this is 1. So this one's ready to go. What does it make? It makes a binomial. The top number will go up front, and that will be in front of my x. And the bottom number will be the trailer, and that's going to be a -3. 3. So one of my factors is 2x minus 3. Okay, now let's look at 2 over 6. Can 2 over 6 be reduced? I would like for everyone to know how to reduce 2 over 6, but, you know, hey. All right, so we got that typed in, and that does reduce to 1/3. So I'm going to scratch that out. That becomes a 1, and that becomes a 3. Now I wrote over here, so I can't do my little funny looking thing, so I'm going to come down here. The top number will go in front of the x, and the bottom number, and again we're using the reduced ones, which is a positive 3, goes right here. So the other factor is going to be x plus 3. And if you box multiply that thing really fast, I want to just prove it to you that it makes the original problem. There's my 2x squared. That's minus 3x, 6x. If I combine those, I get a positive 3x, which is what I have up here. And then a positive times a negative is a negative, which is what I have here. This thing works.